Okay. Good afternoon, everyone. Can you hear me?
Very well, good.
Hi. Okay, thank you. Okay, thank you. Okay, so I will start my introduction. Good afternoon, everyone. If you just join us here, welcome. I am Lee Won Shang from UTAR. I am also the KLESF Secretariat. Welcome to today's webinar, Let's Learn Operation Research. Thank you for taking your time out and being here today. If you have any question about the topic today, please leave them into the chat box. Okay, so now I will start with the objective. The objective of this webinar is to learn about optimization problems such as maximize the profit or minimize the cost. Next, I would like to introduce our speaker today, Dr. Mahboobeh. She is an assistant professor at Department of Mathematical and Actuarial Sciences, Lee Kong Chian Faculty of Engineering and Science, University Tunku Abdul Rahman, Utah. Okay, so now without further ado, we will turn the time over to Dr. Mahboobeh.
Thank you, Ms. Lee, for warm introducing. Hello, everyone. Good afternoon. Thank you for your time to attend into this talk, and I hope all of you are away from the coronavirus. So this talk is about the learning operation research, but I believe that in 30 minutes you cannot learn, but it can be introducing operation research. And you see, if you are interested, then you can go ahead and learn more about that. So and the first thing is that I believe that most of you are not maybe with the background, mathematics background, or statistics. So what do you think about operation research? And you can, if you have question, or you have, if you want to answer my questions, you can type in the chat box, or you can or you can talk. Feel free to talk and ask your questions. So what do you think? Can I have some response that what do you think about the operation research? When you hear operations research, your mind go to which way? So for example, the first time that I hear, okay, yeah, question mark is a good way because it starts to learn. When you have the question mark, then you start to learn. When first time I heard operation research, I was doing my degree, and my mind goes to the research area, that how we can do the research. In that time, there was no Google, and there was no smart phone to Google it and find the answer. But later I found that it is not like that, the definition. So yeah, that's right. Digging through books to learn about the stuff. It was the same thing that comes to my mind. But let's see what we can find for definition of operation research. Usually I start with this puzzle with my class. What do you think is the correct answer for this example? For this puzzle, what is the answer? What is the correct answer for this puzzle? Any idea? Yeah, that's because when we hear about the research, means that we need to go through the books or internet nowadays, but what do you think is the answer? 40, 63, A or D? Okay. Any more suggestion? 30, right. Any other suggestion? 40. Okay, so the point is here is that how I react, how I read the question here. When I read the question, it said that choose the correct answer. If I'm a person without background, without mathematics background, for example, I'm a statistician, but if I'm not, if I'm a statistician, I look at the question like that, it said that correct answer. So correct answer here is 9 times 7 is 63. So here the answer is 63 based on the question, because the question asks you choose the correct answer. The question doesn't ask you what is the answer and what do you think can be, how you can lead to the answer. But however, if you are not a statistician, if you are not a mathematician, then you just look for the answer that follow the pattern. So if I follow the pattern, here I have 13, then is 70, the next one is 12, is 60, next one is 11, is 50, next one is 9. So 10 is missed here. So means that 40 is wrong, cannot be 40, but 30 is another answer. If I follow the pattern, then 30 is another answer. 9 times 6, 9 times 6, 30. 9 times 7 actually, not 6. Yeah, anything can come to your mind. And I have a question from my students. They said that the answer is double question mark is another answer, right? Because we have the times multiply numbers equal something, and the last one is double quotation and double question mark. So that is another answer. So you can see that for one question that it seems very easy, is a puzzle, you have many different solutions based on your logic, based on your understanding of the question. So you have different answer, but which one is the best one? Which answer is the best one for me? That while I'm talking about this example. So I need to go through this kind of the problems. Now I think your mind is kind of changed that what can be operation research about to find the answers. I think Chia Jae-in, you asked requesting for wrongly. Okay. So let's see. Let's go for this example. This is the modeling example, the real example, real problem that usually we face with it. You have a 5-week business commitment between Kuala Lumpur and Penang. And you need to fly out of KL on Mondays and return on Wednesday. And a regular round trip is 400 ringgit. And there is 20% discount if guaranteed the dates of the ticket span a weekend. It means that if your return ticket, you buy return ticket for this Monday and return on the next week, next Wednesday, then you can get 20% discount. That's the definition. But if you buy return ticket for week 1 Monday and return on week 1 Wednesday, then you have to pay 400. If you buy it from this Monday to the next Wednesday for second week or third week, then you have to pay 320 RM. And if you buy one-way ticket, then is 70%, 75% of the regular price means is 300 RM. So how I should buy, how do you buy the tickets? And what is the point if I show up this question? What is the point for making this question? What do you look for when you read this question? what is your goal to solve this problem? Because it's buying tickets, so you can buy it in any way. But if I want to go through it, what's the point if I try to solve it? Yes, that's right. To minimize the cost. So the point is that I want to pay less money to buy tickets because there is some discounts. So the point or the goal for this problem is minimize the cost. So now, again, another things come to your mind. Operation research is about the minimize the cost, because I can use this problem to find the minimum value and how I can buy it. So, but there is something here. Do you have any, are you free to buy tickets on your way? Any way you can buy tickets? Probably not, because here it said that you should fly out on KL on Monday and return on Wednesday. So this is the limitation. You have some restriction, you have some conditions, some limitations, that you have to leave KL on Monday for each week and return on Wednesday. For example, you cannot leave KL on Saturday or Thursday or Tuesday. It should be on Monday. And you have to go back to KL on Wednesday. Other days, if you want to buy a ticket, you are not able to buy the ticket in for other days. So this is the restriction, that I have some limitation. So if I was free to buy tickets in any way, so there was no point to solve this problem. But now I have limitations. So what do you think? How you can buy tickets? How many ways you have to buy different tickets? Is it only one way to buy tickets, or you have different options to buy tickets? Can you give your idea? Can you think that how you can buy your tickets? Is it possible to buy tickets that include weekends? Then you can have the discount. Or for example, if you buy the regular round trip for each week, is more probable, is more acceptable, or buy one-way tickets? Yes, we have usually we have a lot of the questions, and sorry, we have a lot of way to solve this problem, but most of the time, not always, we have the one that is the best one. So here I have many different ways to buy tickets, but it might be only one of them that give me the minimum cost to buy these tickets. For example, consider this one. This is one way, one method, that each week I buy a return ticket for each week separately. And none of these tickets include the weekend. So I go on Monday and come back on Wednesday for week 1 to week 5. So the cost is 2,000 ringgit for this return. But it doesn't, it seems that is not the best answer, because I have to pay 400 for each round ticket. How about this one? This is another way to buy the ticket. I buy one-way ticket at the first week and one-way ticket at the last week, Wednesday, the first from KL and the last from the Penang, and then the return ticket from Wednesday first week and Monday second week is a round trip, which include weekend. So means that for ticket 2 that starts from Penang and to KL is include a 20% discount, and go for the third ticket T1 and then T4 and T5. So means that I can buy 4 return tickets, which these 4 includes weekends. So I consider with the discount, and 2 one-way tickets. that the price is 300 ringgit. So the total cost is 1880. So this one means that this is the less than the previous one. The cost is less than, so means that this is the better solution. Do we have any other solution that costs you less than this value, or you think that this is the best one? Can you think that you have any other way that you can buy a ticket with less price than this? I give you some examples. So this, and then you can figure out about the operation research and what is it and how we can use the operation research to solve the problems. How about this one? This time I have the same rule that I have tickets from Wednesday and the next Monday for the weeks. And the first ticket, instead of buying a one-way ticket at the first Monday and the last Wednesday, I buy another round trip that cover first Monday on first week and the last week Wednesday. So now I have only 5 round tickets, which all of them include weekends. So it means that all of them include a discount. So now the price you see that is 1600 ringgit. So this one is the minimum, or is the less price compared with the 2 other alternatives. And for sure, we have many other options to solve the problem. And the operation research teach you different methods that how to deal with these kind of the questions, how to solve these problems, and how to find the best answer for your question. Let's consider this example. This is a kind of mathematical example, but it is not difficult. So we have a wire with length 10, and you are considering to build a rectangle to maximize the area. So I have the wire with the length with 10-inch length, and I want to build a rectangle. So for rectangle, I need to know what is the weight and what is the height. And for those that you may forget, the area for a rectangle is weight times width height. So how can I build this rectangle to have the maximum area? So now the point or the goal of this question is what? Is maximizing the area, right? So this one is kind of mathematical question. So we have the formula to calculate the area of the rectangle. It means that for this problem, I can use in the formula or the methods, statistical methods in mathematics, then I find the best answer. But if I don't want to use the formula, because in the mathematics, I need to differentiate the function to find the maximum value. But if I don't want to use it, so I can go to methods of operation research to solve. And the other thing is that based on the question, it is not necessary to use all length of the wire. So I can use part of it, like this one, for example. So how many choice you have to find the value for W and H, for weight and height of the rectangle, and which one is the best answer? And the point is that here the value of W and H can be any value between 0 to 10. So you have many options, you have many solutions for this problem. You can give any value. For example, you can give value 2 and 5. I think it should be opposite based on the graph. So, but is it acceptable if I give 2 and 5? Can I give this value to H and W? Do you think it is acceptable? Yes, another answer. 3-2 right, 4-1, 2.5 for both. So yeah, these all are different answers. And your answer is not necessary to be integer values, can be decimal values, can be continuous value. So this one is not acceptable because the summation of 5 plus 2 times 2 is 7. Perimeter of the rectangle is W plus H times 2. So I have 2 plus 5, 7 times 2 is 14. So it means that if I give this value, it is not the correct answer. So I cannot give. So the other thing is that now you know about the operation research. Sometimes you can have the wrong answer as well. It is not necessary that always you have the correct answer. Sometimes the answer that you have not fit to the situation. So that one we call it infeasible solution. How about this example? You are a thief and you have to come to UTAR Sungai Long to steal students' laptops. Please don't do it during these times. They really need it for final assessments. There are 7 laptops in the library and each of them we have the weight and we have the value. But so you can steal these laptops, but the point or the limitation or your condition is that your bag only can carry 6 kg. So what's the point here now? What is the goal here now for this problem? Is it maximize the profit or is it minimize the cost, minimize the weight of the laptops? What do you think? What is the goal for this example? How can I define? Yes, maximize the profit, maximize the value that as much as I can take the laptop. Or I can say in other words that is the maximize number of laptops that I can take. So this one, I have 2 options to define my goal. One is maximize the profit. The other one is that maximize number of the laptops that I can take with mine. But I have limitation. So what is the best answer? So I need to try to find the best answer. So again, we use the operation research to find the best answer. Sometimes for the operation research, for the problems, we can have different definition of goals. We can have different way to find the answer. And for each problem, sometimes we have infinite solution to find the answer. Sometimes we have limited solution. For rectangle, you have infinite solution. But for, oh, actually time is go very fast. So I define the definition. So now you have some idea about the operation research. Operation research, the first was called management science or decision science, is a scientific approach to decision making that deals to find the best design and operate a system, usually under conditions when we have limitation in the resource. So the scientifically is designing a system to find the best answer under some limitation, under some restriction. A system is an organization of the independent components that work together to accomplish the goal. So we have some steps that can go through these steps until we find the best answer for the problem. In other words, operation research or OR is discipline that deals with the application of advanced analytical methods. So in operation research, we use the mathematical methods to solve the problem, but not directly using the mathematics formula. And the first time that operation research was defined, it was during Second World War. And when the scientists, they were looking for the best way to distribute the utilization of the war materials because they have the limitation, so they come up with the operation research or management science. And as I said, we have combined some mathematical models and to solve the problem, but here mathematical models usually give you a specific solution, one special solution, but here with operation research we have many different solutions, and among all the solutions you can find the best one. So generally is about the maximize or minimize, and nowadays you can see that after the two world wars, the tools of the operation research were widely applied. So the application was in business, industry, society, then and they come up, expanded into the field in the industries, and then from there, from the petrochemicals, and comes to airlines, come to finance, logistics, governments, and all of them, they move to develop mathematical models or a system like the flowchart, then to analyze and optimize. So mainly operation research is about optimization. Maximum the profit, maximize the number of the, for example, the items that you want to take, maximize number of the projects that you can take or you can invest, or minimize the cost, minimize the time, minimize the distance, depends on your problem. And nowadays is very famous active academic and industrial research. For example, I go fast to this one, the rectangle. If I go by operation research as a statistician, then I define variables. W and H is called decision variables because I'm looking for the maximize the area, so I should need to know these definitions. And then I need to find the objective of the problem, the goal of the problem, that here is maximize the area. And I have some restriction. So the restriction here that I have is that I have only 10 lengths of the wire. So the perimeter of the rectangle should be 10 or less than or equal 10. Depends on the question, you can consider equal or less than equal. And the other restriction is about the sign of variables, that both should be non-negative, because if the value of W is negative, it doesn't make sense. So this is another restriction, that we only can accept positive value for W and H. So in general, the OR model is written like this, that we want to maximize the area subject to constraints. So the optimal solution for this is both W and H should be 10 divided by 4, which is 2.2. By using some methods, then you can find it. And for the first example, for the buying tickets, the question is that when you do the operation research, is that find your decision variable and define your alternatives, find your objective function, and then define your objective criteria. Then you can solve the problem. So here, the restriction is that we have to leave KL on Monday and turn on Wednesday. And the objective is to minimize the cost. So alternatives, we had it like the 3 examples that I gave you. So all these 3 that we went through it is considered this. I go fast because I lost the time. And the best time is, and the best one is the alternative 3 with the minimum cost. But the mathematical model for this model is model. So if I write it mathematically, this is the model for ticket, for buying ticket, but it seems scary for most of you. But there is another method, there is another algorithm. So I can use this table to how to manage my buying ticket, my weights. And then by using another algorithm, not the first one that is by using formula, I find out that how can I buy my tickets. This is the third alternative that we had already. But all of these, you need to go through the algorithm and learn how to use these. Miss Lee, can we continue or I should stop here because it's already 3:30?
You may continue.
Okay, and so generally, and for OR models, we can write this like this. So we have the optimizing, minimize or maximize the objective function subject to the constraints. This is the general OR model that we always have. And then the point or the goal is optimize the problem. So optimize include maximize or minimize, both of them, depends on the problem. And the one definition that you may need to know or is good is that if your solution satisfies to all constraints, we call it feasible solution. So if you have the way that it satisfies all constraints that you have, it is feasible solution. For example, for the rectangle, I can, if I give H2 and W3 is a feasible solution, but 5 and 2 is infeasible solution because it doesn't satisfy the first constraint. And the best answer among all feasible solution is called optimal solution. Another thing that is very important is that the optimal solution only is best for that model. So it means that if I change the situation in the problem, that optimum solution might not be the best one. So every time that I find optimum solution, that optimum solution is exactly for the problem that we have under that constraints, under that restrictions. Otherwise, I need to revise the model. We have different techniques. There's linear programming. All the objective and constraints are linear. We have integer programming, means that the value that you give to your variables all are integer, like the stealing the laptop or buying tickets. You cannot give 1.2 to stealing laptops like that. And dynamic programming that can be decomposed into more manageable sub-problems. Network programming, some problems from network you can manage with operation research, and nonlinear programming, like the rectangle, because the objective function is multiplying W with H, is nonlinear programming. But buying ticket is the linear programming. And we have different algorithms like graphical method, simplex method, and the OR techniques is using algorithm, not formula. I don't follow formula, I follow algorithm, like flowcharts, step by step, and repeated them. So these are all different methods, different algorithms, and these methods is using for linear programming, but not for the other methods. Maybe for some of them are useful, but not for all. And when we repeat it, it calls iteration. So sometimes we have to repeat many times. Sometimes with 1 or 2 iterations, we can get to the optimal solution. To find the answer, you have these phases: definition of the problem, understand your problem, define your decision variables, what is X, what is Y, like we define W and H, and find out about your restrictions. Then construction, the model, like the model that we have for the tickets, and then solve the problem, find the optimal solution for the problem. Then validation of the model, we need to check if that solution helps to the company or the problem, the person in charge of the problem or not. If it is validated, then we can use that solution to solve the problems and go through the, for example, industry or anything else. And it is like the flowchart. So that's why we call it operation research. It's not mathematical method, it's the algorithm that you collect the data, develop the model, check the model if it is accepted or not. Then at the end, if it is accepted, then you can collect the result and analyze it. And they have many different applications. Urban planning for the cities that they want to develop the city, they want to build new city, or they want to prepare public, for example, public transportation. These kind of the problems go for urban planning. Currency arbitrage, because the business are among different countries. So to manage the difference between currencies of different countries, we go for this application. Investment, if you want to take the project, invest in different projects, or in the bank, if bank wants to give loan to the customers. Production planning, that how many products I want to produce each month or each year or each quarter. And manpowering, how many people I need to employ, I need to hire to produce enough production. And some of them we need to maximize. For example, for investment, we need to maximize the profit. For manpower, we need to minimize number of the people. These all are the important application in LP, in the OR. Okay, so I have another examples, but we don't go. This one is another example that we want to model from cross the river. Or we have bank loan model. So this is investment example. Or we want to schedule the bus for 24 hours. And this is the manpowering example. Okay, and that's it. Thank you for listening. And if you have any question, you can ask. If you want to know about the answers, I hope now you are interested to go and learn operation research. So any question you can ask. Any part you want to know more? And it's past, it's after time. And no, actually, the operation research and optimization is not different concepts. They are very related to each other, because operation research is the methods that you learn for optimization. So for optimization, you can use mathematical models sometimes. Sometimes you cannot use mathematical models. So operation research helps you to mix some mathematical methods to find the best answer for kind of the problem that really you don't have the mathematical formula. For example, for buying tickets from KL to Penang, we don't have exact formula in mathematics that how we can minimize the cost, because there is no any rule. We have different situation, but by operation research we can use, again, we use mathematics, but not directly, and not like the way that we use it, for example, for the rectangle. So it is not different concepts, they are very related to each other. Yes, you can have the qualitative as well. So for example, what do you mean by qualitative approach? Because it's about maximizing and minimizing mostly. So depends on how do you define this one. So sometimes it's, for example, I want to send a seller. There is a question that the company wants to send bookseller to different cities to maximize the profit. So that one is not like the mathematics is not quantitative, but is like kind of qualitative. I hope I can answer your question. $4 years, not 4 years. Actually, it's very wide. The area is very wide. So not 4 years, but in one semester is a course in the with 3 credits that now actuarial science and applied mathematics, they pass the course, but this course is for only one application, one technique, that is linear programming. So if you cannot learn it all techniques in one semester or one course, but you can have the idea about the operation research. Then for some simple questions, problems, you can use it. And not really, because it doesn't really go through the advanced mathematics, especially for linear programming. Like these questions, these problems that I show you, you just need to know a basic mathematics. You don't need to go for the advanced mathematics. Because sometimes you don't need even write the formula, like for the tickets by tickets, you see that I show you the mathematical model, and also I use another algorithm that is the table, and you can use it. For that one, you only need to know about the basic mathematics to like addition, subtraction, multiplying, like that. About OR and artificial intelligence. That's an interesting question, but I think that can help, because especially in networking, in the techniques of the networking, operation research networking method, they are very related, because when you go through the networking, you can use the different algorithm and methods for artificial. I'm not very familiar with the artificial intelligence. I know a little than common knowledge, but I believe that for the networking, it's very, and for the dynamic techniques, they are very related to each other. So it's very helpful if you have the basic knowledge about the operation research. That's some special methods. And of course, there are many softwares now that you can use the software. The easiest one is the Solver Excel. So if you are familiar with the Excel, you can use Solver to solve the problem. The point is that you should be able to write the model. You should be able to understand the objective function, what is your goal, define your decision variables, and then define your constraints. What are your limitations? Then, even if you don't want to solve the problem by yourself, you can use softwares. But the first step, you need to do it by yourself, to write the LP model, to write the constraints or understand them. So, any other question? Mr. Mayo, I hope I could answer your question about the qualitative approach, but if not, you can ask more clearly, then maybe I can give you the better answer. Are you curious about that, the answer for the laptop? That which laptop you can steal? What is the optimal solution? For the end of the class, I can give you the answer. I see that, I think you can still see my slides, right? So since there's no any other question, so I give you, this is the mathematical model or LP model for this problem. We define the variable that I take the laptop number I or I don't take it. So the value of X is 0 and 1. And I have only one constraint, the limitation for the weight, and for maximize the profit or the value, And this one is integer programming because all the variables are binary, 0 and 1. So it's called integer programming. And the way that we solve it is branch and bound. The method that I mentioned is branch and bound. And by that, I can find the best answer is stealing laptop number 2 and 3. And the profit is 2800 RM, the best one. So this is the graph that you can solve the problem and find the best answer. Maybe that makes you more interested, more motivate you to go for operation research and learn these kind of the methods and algorithm. Okay, so since there's no any other question, I pass to you, Miss Lee. Thank you all for your listening, and I hope you have a rest of the day. Good one.
Okay, thank you, Dr. Mahboobeh. Okay. Okay,
You're welcome.
anyone have any questions? Some more questions? Okay, so Dr. Mahboobeh, I think there is one more question.
For the rectangle problem, it goes fast. And not necessary for the height and weight can be equal. As you see, the optimal solution for rectangle both should be 2.5. So it gives us the square, not rectangle, but a square is a special shape of a rectangle. So it doesn't violate any condition, but it is the best answer. So there is no limitation that weight and height shouldn't be equal.
Okay.
Okay.
Okay, any question from you guys? Okay, so while we for other question, I will just like to remind that we have prepared the feedback form. So I've just posted the link. Would appreciate if you could help us to fill up the feedback form so that we can improve. Or if you have any suggestions or what Dr. Mahboobeh can talk in the future, you also can let us know. Okay, so anyone, any more questions? Or if you can't if we can't answer your question or anything you want to ask, you can email to me or to KLESF or to Dr. Mahboobeh.
Yes, sure. Yes, my email is mahboobeh@UTAR. So maybe I can show you here. If you are interested, I can add in the chat box. So if you are, feel free to ask question through my email. You're welcome. Thank you and bye, all of you.
Okay, so okay, I guess there's other questions. So if you have any questions, just leave. Sorry, may I know who is speaking? Are you asking any question?
I think it was by mistake, but I don't know.
Okay. Okay, so before I end, just a reminder, kindly help us to fill out the feedback form. Okay. I would like to thank Dr. Mahboobeh for the sharing session today.
You're most welcome, and thank you you too for organizing and set the meeting.
Okay, so if
Have
you
a good day. Bye.
If you hope Dr. Mahboobeh to have another talk, please let us know. Thank you everyone for joining us today. So we really appreciate you being here. If you would like to know more about KLESF virtual events, Please like our Facebook page, KLESF Kuala Lumpur Engineering Science Fair. We have more of our virtual event at our page. Thanks again for joining us today. Okay, we will see you next time. Thank you. Bye.